Okay, this problem is easy peasy. Hopefully you learned at some point the relationships of the sides of a 30, 60, 90 triangle. This problem tells you that this angle is 30 degrees, that this angle is 60 degrees. So in a triangle, they all have to add up to 180. The other side has to be 90. That's a 30, 60, 90 triangle. So I'm going to draw that triangle out over here. And I have an extra little speck here that I'm going to erase. Okay, so this is the 30, and opposite the 30 is the one side. The hypotenuse is the longest side, so that's 2 times the one side. And then opposite the 60 degrees is the square root of 3 side. Okay, so that's the square root of 3 times the short side. Now, this tells you that the distance from A to B is 21,185.5. That's this part right here. So this side is 2 times that. So if we take a calculator and multiply 21,185.5 times 2, we get 42,371. So this side is 42,371. Okay, but it tells you the radius of the Earth is 6371. So the radius is 6371. That's from the center of the Earth to here. So we have to subtract out the radius. Okay, so we take this 42,371 and we subtract out the 6371, and that gives us the distance from the Earth to point B, okay, which was 36,000. So 36,000 kilometers is the distance from satellite B to Earth. And then for satellite A, we're going to do the same thing. We're going to take that side of 21,185.5, and we're going to multiply that times the square root of 3. So bringing over the calculator, we take the 21,185.5 times, and we're going to take the square root of 3 times that, and we get that 36,694. So 36,694.36 something something something. Okay, and it goes on forever, so it depends how accurate your instructor wants you to be. But again, that's the total distance from the center to A, so we have to subtract out that radius of the Earth, which is 6371. So when we take that 36,694 and then subtract 6371, we're left with 30,323 point something. 30,323.36 kilometers. And so that's the distance from the Earth to satellite A.